Hi guys, welcome back. So from last time, I've shown you that how to use the JMOAB to control the PWM cart or the robot that has the DC motor with an ESC. For today, I'm going to show you how we're going to use the JMOAB with some of the robot application. So let's get started. The application that I would like to do it for today is the apple following. So the reason that I use the apple because I have some like a fake apple model like this, like a lot of this. So I think it's a good object for the robot to detect and like let the robot following the object. So the idea is like we have the AT card here, and then there is an apple that placing on the ground, like kind of like a route for the robot to just follow. So the robot will have some camera in front here. And then it's going to run the object detection, and the robot's going to move and detect the apple, and then just go over it, and then detect the new one, and then just move, like steer to the next one until the end, like this. So if the apple is just lining up as long as possible, so this robot just keep going. For example, if the apple is lining up like a curve like this, the robot should be able to steer in the curve as well, like this motion. So for this application, I'm going to use the OAK-D camera because it has the neural network running inside the camera. And of course, our just a Nano, it has the GPU. But because of the custom image that we use to run Ubuntu 20 for ROS2, there's some like many missing package like TensorRT and CUDNN. So I decided to use the OAK-D instead because everything is running inside the camera, and then we can just get the data out from the USB, and that is easier for development. So the algorithm that I'm going to use is like once the camera detects the apples, I'm going to grab the center coordinates of the bounding box of the apple, and then use that x coordinate to define that which direction that the robot should steer, like how much left it should go or how much right it should go. For example, if the apple is stay on the left side of the frame, then the robot should steer to the left to follow that apple. But of course, there might be a possibility that the apple will appear in the frames like more than one. So in that case, I'm going to calculate the center point between these two apples. If it's just a one apple, it's just an easy. But when there is a two apple, so I'm going to use this line. So we can construct the line from the center of this apple, and then do the average to find this black point. So this black point going to tell the robot where to go. So when there is more than two apples, I'm going to use the linear regression to estimate what is the best fit line that fit for these three or these four apples. So, and then I'm going to find the middle point of that line, and then use that point as the value for the robot to steer. So it's just a simple algorithm that I think it should work. So let's see. Okay, so I took the just a Nano out from the robot and work it on the desktop just to confirm the camera working first. So first thing first, we need to install the depthai package. So in order to do that, we're just going to open the browser, like check on the website of the depthai Python. You could see how to install that. Search by depthai Python. It's going to show you the GitHub repository. Then all you need to do is just install by pip. it's better to clone their GitHub to test some code first. Then here I already have one. Here, depthai Python. You can go to example, and then you better to run the install requirement by type Python, Python 3, install requirement, and then it's going to install some of the package dependencies and download some pre-trained model like a blob file that you can just use. You can check on the YOLO. When I test on YOLO v3, it's give much more better. Then yeah, you can see that it's showing a lot of things. And this is just a person. So we can prove that now the OAK-D and the JSON Nano is working together. So next we're going to create our own project and make our own code to detect just only the apple. And we're going to make directory which call apple following bot like this. Then apple following bot, so nothing there. Then I'm going to make another directory inside which called model. So if you go to here, the wait a moment, depthai Python, and go to examples, and go to wait a moment, model. Okay, so you will see that there is a lot of model that you can use. And if I just list, but I'm going to use this YOLO with the tiny, so I'm just going to copy this to the home apple model. So here we have the model and with the YOLO with the tiny. Okay, then we're going to make some code. But for easier, I'm going to develop it in my laptop and then transfer it to the JSON Nano by SCP. So first we need to make sure that we can SSH to the robot on the JSON Nano. So SSH JSON 192.168.8.129 for desktop development. Okay, here is we are in the JSON Nano. So I'm going to make our own. Here, let's put it on left and right side. We can know that this one is the laptop. So I'm going to make directory apple following bot. So X, then cd into there. Next, let's try to make the apple detection code. So if you wonder that what code we're going to use, so I recommend to go to the GitHub repo and check on the example and the YOLO, tiny YOLO. So most of the code that I'm going to put into this apple detection.py is pretty much kind of same in here, but we're just going to like tweak something in this while true loop, get the coordinates of the bounding box and just print it out, something like that. So I'm going to show you how to do that now. That I want to copy, which is here the label map. Here, let's make it a little bit smaller. Then we're going to create the pipeline. Okay, and then for the RGB camera, need to specify some configuration. YOLO detection, NN. And then we need to set up the X out. So next we need to define cam RGB dot preview dot link. Yeah, it's quite a lot of configuration when you're using OD camera with the Step AI. Then next is the important part, is the die statement. Then we are ready to go grab the frame in the Y through. We just simply put like in RGB and Q dot Q RGB dot get. Yep, this is a CV frame. This is also the CV frame. This is an object, so we can grab the output object of the detection and do something on the display frame. Here, let's try run it first and see what we have it now, or if there is an error or not. I'm going to SCP Apple detection into Jetson at 192.168.8.129 and home Jetson Apple floating bot. Okay, go. So I just place it there. So I'm going to switch to Jetson. So this is a Jetson Nano desktop. So I'm going to run it here locally. X out RGB is not defined. Okay, I think I missed something. Let's go back and see what we have missed. Yeah, of course. My eye just forget to put this line. Okay, and just copy this to this nano and then run. Let's try also print something. Then we can see that it's working or not. Okay, we just copy this to the Jetson Nano. I think we can even try to run it from here as SSH. So, okay, cool. It's running actually. Yep, it's showing the CV frame. And this is the object from the detection. So we need to just grab some data from the detection and put it on the display frame. And just remove this line for detection. The 47 is the Apple object that we want to use. So if it's not 47, we're not going to do anything, just skip that. But if it's 47, then we want to grab, first we're going to grab the height. I've added this line because I found that sometimes there's some infinity, but not many times. I'm not sure, maybe they have fixed some bugs inside of the depthai Python. But anyway, I'm going to put this just in case. Okay, then next we're going to grab the x min x max, y min y max. Because the output of the x min, x max, y min, y max is in the normalized value, so we want to use the pixel value like 0 to some numbers like 120, 1280s or 640s or something. So we want to use that numbers instead of the floating numbers. And after that, with these x min, y min, x max, y max, we can draw the box. So this should be enough to just display. We say that if out of the for loop. Okay, so let's try this first and see if it's working or not. Copy to there, and I'm going to switch to just nano. Then Python 3 and Apple detection.py. Oh, width. Width, haven't defined. This should be in this level, yeah. Back to just nano. Okay, it's kind of detect. Let's see, oh, okay, could detect. Let's try to put here. But I think there's some things wrong that with the coordinates. Probably I just put the wrong number or something. Let me check. So here, it should be something like this. And then copy again. Okay, now we can detect apples and showing the bounding box and confidence number. So yeah, it looks not that bad. Of course, it's not perfect because this tiny YOLO v3 and it's also convert to the blob file. So it's not that perfect, but we can detect something. Let's move on to our code. So far we have grabbed the frame and draw something on it. I want to grab the center coordinates of the bounding box and then draws the line to it like this. So let's try to grab the center coordinate. That's it. Then let's try to check it again. Okay, so you can notice that there is a dot on the center of the bounding box now. So far we can get the detection frame from the OAK-D camera, and then we draw the bounding box on the apples, and also we get the center coordinates of the bounding box. So next step, we're going to apply the idea that I've explained at first about the calculate the line and average those 2 points as a single point on the line. So next we're going to do that, and let's stay tuned.